let's discuss here about the partition. So we have a data. Okay. Now data, suppose 100 GB of data, it is getting divided into 20 partition each. Okay. 20 GB each. Okay. So it is creating 4 or 5 partition, or 25 GB if we consider, that is creating 4 partition which can process parallelly if we are considering that partition size as same. Okay, but that cannot be the case, but we'll discuss that later. Okay, let's deep dive into that part. Now Spark, we have we have the execution plan, we have the data. Suppose the data got divided into 200 partitions. Okay, our task, now we can consider that our task, there is 200 tasks. Okay, now to process the data, as Partho was saying in first day, now to process the data we don't only need RAM. Okay, along with this we'll need core. Okay, suppose you have a system. Let's go to the previous example. In a system you have storage, that is hard disk, you have RAM, that is your memory, and you have core, which is responsible to process the data. RAM is the place where the data will get processed, and the hard disk where we'll store the data. But core is responsible resource or item, you can say, who is responsible to process the data in the RAM. Okay, so each executor is, you can consider it as a computer. Okay, consider it as a computer. So each executor or a computer can have multiple cores. I mean, quad core processor, maybe you have heard. Quad means four. So 4 core processor. Okay. Let's take example uh, of quad core processor. Suppose we have created 4 executor and each has 4 cores. Okay. And 8 GB RAM each. Okay. Now our data, we have provided 100 GB of data. Okay, now our driver node will divide that into tasks. Suppose our execution plan will get divided into tasks, and based on our partition, suppose we have 200% partition, and let's consider our 200 tasks got created. Next 200 tasks will go to each executor. Okay, each executor 200 tasks. Okay, now suppose let's assume that we have divided our task first sets of tasks into each executor. Now each executor, you can see in the screen, has four at a time it can complete 4 tasks each executor. That's mean we have 4 executor, 4 into 4 is 16. At a time in parallel 16 task is getting completed. Okay, now when, suppose from the first executor uh, completed the 4 task, then another 4 tasks will get assigned to those executors. Okay, likewise, for 200 tasks will get completed in this case. Okay, this is the process basically.
Someone can get confused here that four tasks are getting pointed to four core in the to executor. That doesn't mean that only four tasks will get assigned to four executor. Here we can see 200 partitions are available in the example. So out of that, 16 tasks will get assigned to the 16 core available in four executors. And after that, when some jobs will get complete, that means some task will get complete in executor, which executor will be empty, that there another task will get assigned, and simultaneously parallelly it will process and complete 200 partitions, I mean 200 tasks here altogether at the end.